In this project, we will be building a machine learning model and deploy that model by building a web app that is using Django framework and using the Heroku application where we are going to deploy it. The dataset used is the video games dataset that is like pretty much clear from the title also. Moving forward, so what are we going to do? Actually, we have a data set containing attributes related to sales of a video game or sales of the video games that is present in our data set. Here, we predict the sales of video games in a particular region, and the regions are defined just like I have specified, that is NA region, EU region, JP region. Okay, the spelling is wrong, but JP region, and all the other regions are accumulated and set into the other region. So since I live in India, I'm going to be a little partial and predict the other region parameter. One thing another to note is that this dataset is not specifically built for prediction, but for analysis and finding key points in the data about video games. Meaning that this dataset was created so that you could find specific key points that might help a company in maybe delivering or in maybe increasing their sales of a video game that the company has built. So this dataset was actually built for analysis, but since this is a very enriched data, I'm going to use that for prediction also. So details of the project. Now the project is divided into three parts. The first is building a machine learning model to predict the sales for the other region variable. The second part is where we build a web application using the Django framework and mount the prediction model. And the last part is that we are just going to deploy this Django web application on GitHub. Oh, sorry, on Heroku through GitHub. So the first part, that is building the machine learning model. Here we start off building the machine learning model using the linear regression model and train that model using the video game sale data point. So this is pretty easy. We're just going to use some methods to first pre-process the data, then input those pre-processed data into the model and find out the accuracy, if it is high, low, why. Next is Django web app, basically creating our web application. So this is the second part of the course where we build the web application using the framework Django. We mount the model we built in the previous part on the Django project here. The last part is deploying on Heroku. So this is the last part where we deploy the Django application on Heroku using the connections to GitHub. Now Heroku provides three processes by which you can deploy, and we are going to use the process where it actually takes a little bit help of GitHub to access the code. So now let's move on to the first part of the project, that is building a machine learning model. So this is the first part of the project where we are going to build a machine learning model, and simultaneously we are going to train that model on the pre-processed data set. Now I'm using Google Colaboratory, and the first thing that we are going to do is mount the drive so that I can access the files from my drive to the Google Colaboratory. And for that, we are going to use this code here. So once you do this, it would ask you to sign in, or maybe if you have already signed in, then it would give you the output as mounted at content drive directory. Then the next thing we are going to do is import the necessary libraries that we are going to use now. So the basic libraries for pre-processing data or manipulation in data is NumPy, Pandas, Seaborn, and Matplotlib, where Seaborn and Matplotlib are for visualizing the data. like making graphs, like histograms, maybe box plots to understand if there are outliers in the dataset or not, and many more different type of graphs to understand more about the data. The next, we are going to use the sklearn library and import linear regression and train test split function so that we are able to build our training data and test data and then input that into our linear regression model. So I've actually got this data set from Kaggle, and if you want to look at more or you want to understand more about the data, you can just go to this link here that I have presented. Okay, so now yeah, I'm going to use the read CSV function and call my data set, that is video games sales.csv, and using the head function, I can output the first three data points from my data set. So you can see a lot of columns are present here, and you can see a lot of nans are also present here. So anyone who is even a beginner in machine learning would know that we have to get rid of all of these nans, and that can be directly by removing these rows or by actually using a filling function so that I'm able to fill in this data point, sorry, that has a nan value. There are even other methods, but most probably we go with either of the two that I have just now said. So looking at the columns, it is telling you the name of the video game, the platform it works on, year of release, the genre, publisher. Now these are the sales values that are NA sales, EU sales, JP sales, that is Japan, and then other sales that are like regions other than the three provided before. And then the accumulation of all of these. Then you get a critic score, and don't ask me who the critic is, I don't know. It is maybe accumulation or average of all the critics, or maybe just one. And then the critic count, again, just as I said, whoever these critics are. Then the user score and user count, the developer, and lastly the rating. These rating are not like 5-star, 4-star rating. These rating are like for PG-13 types. Yeah. So we got a lot of columns, and looking at these columns you might understand that some of them there are just integer or float values, but some of them actually have a lot of categories in them. Like a genre column has a lot of categories of sports, racing, action, fantasy, mystery, or some other, but you get the point. Similarly, for platform we can go like that. For developer, maybe not, since there might be a lot of developers here. The rating, we can go for that. So you will later on see how I'm actually using or manipulating these categories and extracting data from them. Here you can see that I'm using the shape parameter, and it is giving me the cardinality of the data set, telling me that there are 16k rows and 16 columns. Now the first and foremost thing to do is look for null values. And from here you can see that I'm using the isNull function that returns me null values present in the dataset, and .sum function that is telling me the count of null values present in my dataset, or more specifically the count of null values in each of the columns. You can see there are two null values in name. There are 269 null values in year of release, and you can see it ranges from 8,000 to 9,000, actually from 6,000 to 9,000. So this is a very large number of rows that have null values present in them, meaning that this data set, however collected, is not actually very good for prediction purposes, I would say, because more than half of values inside user count are null. Okay. Now, if you directly delete them, then the number of rows that are present would go from 16k to 7k. More than half have been removed directly. Again, what you can do is take a parameter on which you're removing columns, and the rest over columns that have present, just input or fill it using some criteria. Now, this is something that you might be not able to understand clearly. So I would give the example for this just below. Okay, what you can do is you can see that for most it ranges from 8,000 and 6,000. So you can just directly remove this column, okay, and then try to either fill it up or remove the rows for all of that data set with some specific format or particular reasoning. Say you can see, yeah, you can see here for the ratings column, the ratings, it has 6,769 null values. What I am doing is using the not na function. I will tell you what this is doing. So basically, I am taking all the rows from the game's pandas dataset, and only those rows are being picked where the value for rating is not null. Meaning, let's go back. Yeah, here you can see that the rating is a null value present, meaning that this row will not be picked up by not any function. So this and this rows, actually these rows will be picked up, and the new dataset that would be built would be of this and this row. So this row will be excluded. So this is what NA does for a detailed and correct description. I would say not any function detects existing non-missing values in the data frame. Okay, the function returns a Boolean object having the same size as that of the object on which it is applied. Object meaning it can be a row, it can be a column. Okay, indicating whether each individual value is a NaN value or null value or not. So since we are working on the rating column, so we are going through each and every data point in rating column and looking for null values. If a null value is not present, then that for that row, a true is mapped, and then in the games filtered, that row is inserted. But going through the rating column, if we find a null value, then for that row, a false is mapped, and then that row is not inserted into the game's filtered data frame. Okay, now you can see that I've again used the is null and some combination, and now the rating is actually having no null value, meaning all the rows which had an existing value in the rating section were inputted into the game's filtered data frame. And coincidentally, even the developers is having zero null values, and these also have reduced considerably, and even the year of release has decreased a lot. So still we have now 9,950 data points, and even then there are 2,000 data points, more than 2,000 data points that have null values in them. So what you can do is either remove these rows also, or remove the column itself, or fill it up. But if you fill 2,000 data point values, then your data will become biased. So that is not an approachable method, because if you're filling only maybe 180, 200 data points for 10,000 data points, it doesn't bring much change, though it does bring a little change or little bias into the data set, but that is still okay in comparison to 2k data points missing and filling them. So this is what I have done, and this is what I've done later on. First, what I want to show you is the value counts function. So what this gives you is something like a dictionary where it would provide you with each and every unique data point, or I would say each and every unique value present in a column. Okay, like I'm using the year of release column, and associated with the number of times it has occurred. So 2009 year has been occurring for 1011 times. Okay, similarly for the rest of it, and you can see that a lot of values are present here. Next is I'm again looking for publisher column, and in publisher column using the value counts I can see that Electronic Arts is present for 1139 times. Okay, and similarly for the rest of it, but here you see that the length is 332. Now if I'm trying to use this data, I would say data column, as a categorical data type, then 332 categories will be present. Again, you can't actually use so many categories in any manner to produce or extract information that might help the model in learning during its training process. But since I have some alternatives that I'm going to use, it is not like completely useless. Similarly, I'm looking for user score, and here you can see what I was talking about before, that I am again use the not NA function so that all the null values from critic score is removed, from critic count is removed, from user count is removed. Okay, and since year of release had a lot less null values, I am filling it with the mode value, that is the most occurring value in that column. Similarly for publisher and user code score. So lastly, just for validation, I am using this null.sum combination to see if any null value is present. But as you can see, no null value is present now. But again, the data set has been, shortened considerably, and this is a basic, I would say, note I might give you, that if we were working on an industry level project, removing so many data points won't be allowed. Okay, so either what you have to do is again build a better data set, or try to find values that you might be able to use to fill the NN value. Next, I'm using the describe function. Okay, so in describe function, this function gives you a brief statistical viewpoint of your data set for all the integer or all numerical values. Now, I won't be considering this as numerical values because this is actually years, 2007, 2010, such that. But NA sales, that is the value for sales in North America, or EU sales in European countries, Japanese sales, and other region sales. I would be taking these as an example and give you a reason why we are using the describe function. Now see, the minimum for this and the maximum for this. Minimum goes to 0 and maximum is 41. It's rounded off. Yeah, it is still 41. And again, it is for 0 and 28. Goes to 29. 0 and 7. So here, you are finding that all of the ranges, like minimum to max, are comparable to each other. That is good. But if in your data point or data set, you get a column or some columns which have their ranges too far apart. For example, maybe a range is from 1 to 10 and the other is from 10,000 to 55,000. Yeah, these ranges are very far apart, and the problem is that the model, once it takes in these kind of columns as its input, it is not able to generalize well or find patterns which might help in prediction. So this is kind of an indicative method where you can see if the ranges are too far apart. If they are, you can use the processes like normalization or standardization to bring the ranges in a more concise and comparable manner, while bringing the distribution curve also into a bell curve. So this is the reason I'm using the describe function. It also gives you the 25 percentiles, 58 percentile, that is the mean, and sorry, the median. The mean is also given. Now you can see that there's a 10,000 here present and the minimum is 4. So here if you want, you can use normalization to bring the ranges a little bit closer and comparable to the other ranges. The next you see is that we are building a correlational graph for the data point or the data set. So here what we are doing is, for each and every column we are finding the correlation to the each and every other column. Meaning, let's say year of release as our first column, we are finding its correlation to year of release, NA sales, U sales, and all the other columns. And those values are stored here in this row. Okay. So again, why we are doing this? This is because while my data set is not very large in comparison of columns, when we compare the number of columns we have, if your data set has 200 columns, this is for example, then if you directly try to input that big data set into your model, it is going to take a lot of time. And even the prediction accuracy is not certain that you would get a very high prediction accuracy. So what we do is we try to minimize the number of columns present, and there are various methods. You can use PCA to understand the most influential columns that you have in your data set and only pick some of these. Or what you can do is find if two data columns are very similar to each other. If there are, then remove one of that column. So for this purpose is what we are going to use correlation graph for. Here you can see for the values that are very much closely related to 1 or minus 1, it means that for 1, if the value is actually closer to 1, that means that the two columns are very much highly correlated, meaning that they are going to give same kind of information to the model. If that is so, then we are going to remove one of the columns. Again, uh, if the value is really very close to minus 1, then that means the column A, let's say, is highly inversely correlated to column B. So it's your wish to remove them or not, because what happens is sometimes you can see that since we are going to predict for other sales is very much correlated to global sales. Yeah, so that means that your prediction value is very much related to global sales. Okay, that means that global changes in global sales will very much, I would say, influence the other sales parameter or value. But you can see that I'm going to remove the global sales value, and the reason being, if I have the NA sales, EU sales, JP sales value, but not the other sales value, then how can I compute the global sales value? Since the sum of all of these is actually equal to global sales. So I'm going to remove that. And you would see that the accuracy of my model pretty much decreases. And one of the reasons for that is that I am going to remove this global sales variable or column that is so much related, highly related to other sales column. So next we go for, yeah, you can see I'm removing the global sales column, and now the number of columns that we have been reduced. And with this, we might be starting with feature engineering, that is extracting more useful information from different types of data, like categorical data, or maybe from other type of data. Okay, so I'm taking the platform column, and you can see that I'm again using the value counts, and it has given me the different platforms present in my dataset and the number of times they have occurred. So again, if I have to directly build a category, then the number of categories would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Now there's 17 categories. So if I were to use each category as a column later on, some of you might have understand what I'm going to do. But for example, if these 17 categories were to be built as new data columns, then 17 new columns would be built. That means I'm increasing my dimensionality by 100%, which is a very bad idea. So what I'm going to do is I'm going to take the 1, 2, 3, 4 most used consoles that I get from here, you can see, and the rest I'm assigning them as other console. So you can see that now my platform has, I have just built a new column, platform new, and it has the value other console. Whereas in my previous data set, it has, oh sorry, this developer, this where's, yeah, platform has V. I'm going to do this for some of the more columns, okay, because again I have to somehow diminish the number of categories so that I can use those categories later on to build new columns or data points and use those, I would say, the new data set as my input to the training model, that is linear regression model. So here you can see that I'm again using a new function, that is map function. Meaning, what this map function takes as input is the name of the or dictionary or name of a function. Okay, so here it is taking the platform as an input, that is a function. And what map does is for each and every data point inside platform, it is going to use the platform function on it. Meaning, let's say that the first data point comes as V. So the platform function will take input as V and then search for if V is present. Since V is not present in any of these, then it would assign the other console. So now in my platform new, other console is returned and inserted. Similarly, in the next, then it would go to the next input, that again would be some console, and that console would be checked. If it is a PS3, then it would return PS3. So in my publisher new, PS3 would be inserted. So this map function works on each and every data point inside that column. Okay, and according to the function, something is returned. Now, the next is genre. Okay, and similarly I'm finding for each and every column that can be a categorical column, and you can see that developer again is a categorical column, but the number of categories present are a lot, and at one point it just becomes 111. You can see just it has been occurring for only one time and not more. So again what I did is took the first five most occurring or influential type of developers, and did the same thing using the map function, giving it input as the developer function. Then on each and every data point of developer, this developer function will work and assign the values accordingly. So here you can see that in develop. Okay, that was an abrupt stop. Sorry. So here, moving forward, you can see that Nintendo is now present here, and here the publisher was Nintendo. So this map function, as you can now understand, is taking each and every data point using some logic and returning something that is specified by the publisher function or any function that you have inputted here in the map as parameter. Next, I'm all removing the unwanted columns from my data set since I have built the new platform, new publisher, new developer, even the new rating. So once all of that has been removed, I'm now segregating my y, that is the predictive that I have to predict, and the next thing I'm doing is extracting my data points. Now for people who don't know, getDummies is basically helping, okay, getDummy is basically helping in extracting data from your categorical data types by what it does is that it gives you some new columns and assigns value 1 and 0, meaning here you can see the platform new. Basically, we have understood that the platforms would be PC, PS2, PS3, Xbox. Okay, so another console. Let's say that for the first value, not even let's say, let's just go directly here. You can, okay, not here. Yeah, you can here. You can see here that the platform was B. Okay, so since B is not defined by any of these, that is B is defined by other console. Thus, we use 1 here and set 0 for all of these. If a data point had PS3, then what would happen is that 1 will be present here, okay, and the rest of the columns would be set with 0. So this tells you that in one column where there were some categories, you can extract that column into several columns, and that is helping the data, or I would say that is helping the model train. Because otherwise what you would have to do is that directly remove those columns, because models can't understand string data types. It only takes numbers or integer float values. Similarly, what I did is for developers, for my ratings, and for the publishers. Yeah. So see, the first in the first row, the publisher was Nintendo. Here you can see that 1 is present for that and the rest are 0. Similarly for other columns. Now you can see that using the columns parameter, I can see that I have now increased the number of columns by a lot. But still, these are between 20 or maybe less than 20. So it is still favorable. And now I'm using the train test split function to split the data into training and testing data. Using the linear regression model, training that, get an accuracy of 61, which is shit, I know. But again, like I told you, two main reasons for that is first, this data set was not built for training, or sorry, for prediction. Second, that a column that was highly related to my y, I would say to my target variable was removed. So a lot of information that would help in prediction of my target variable was removed. That is the reason why this accuracy is so low. And what you can do is to increase the accuracy by somewhat maybe 5 to 10%. You can go for hyperparameter tuning. I haven't done that since the basic purpose of the first part was to build a machine learning model and learn what you have to do before building and what you have to do while building the model. Okay, so yeah, the testing is even more shit, I know, but you can increase or you can use some other functions or method to pre-process the data and then try to train the model. That is on you. So once you have done that, you can use the pickle package or the pickle library to save this data, or I would say this save the data of the model, which is helping in prediction. So there are a lot of matrices, and yeah, actually there are a lot of matrices defining the weights for this model and the bias. So those are actually saved in this, I would say, video games model, not pickle. Yeah. So with this, we can say that we have ended the first part of the project, that is building a machine learning model. And now this saved pickle file is what we are going to use to mount this model in our web application, that is using the Django framework. Hi. So this is the second part of the project where we are setting up or building a web application using the Django framework. Okay, so first of all, Django is based on Python, and Django gives you a lot more authority, yet is easy to maneuver and use. Okay, once you understand that what is basically web application, how do you handle request, what happens from a client side and from a server side, you would be really easily able to use Django. And that is because Django gives you a base, already provides you with much that you don't have to code. Most probably what you have to do is basically use the base project, build upon it, maybe modify it, but that's it. And even in that, it helps you in a lot of ways by providing you with middlewares, by providing with you, sorry, by providing you with ease in accessing and maintaining databases and such. So first of all, this in this code we are trying to set up so that we can use this code locally. So for that, what you have to do is just create a project directory. Okay, once you have created a project directory, store this code there, and then for this code build an environment for this code. Okay, or I would say for the project. So what is an environment? So environment is basically a setup that is excluded from everything related to your code or from your computer, or I would say this environment is isolated from each and everything and is only dependent on a particular code, where you can store packages, where you can install directories, or maybe not directories, install maybe wheels and such. Basically, all of the packages and dependencies that you're going to use in this project will be stored in an environment that is isolated from other environments or maybe from other packages that you have already downloaded. So why this is useful is because once you have created an environment, it is easy to destroy the environment when not in use, to update, modify the environment without actually making changes to other part of the program or other packages that you have installed. So once you have done that, go inside the my site directory. Since this is the code part, you can go into the my site directory, and there what you have to do is go to your command line and write cd my site. So you just have to write once so that my site is present. Okay, so once, like, salary determine is something that I have given as a name for my project directory. Inside that I stored the code, and then in my command line I went into the my site directory. Now here what you have to do is just write pip install r requirements.txt. What this does is that it will install or maybe download and then install each and every dependency and package that are required by the project. Okay, once you have done that, once you have done that, we can move forward and in the same directory, in my command line, write python manage.py migrate. Once you write this command, this is actually related to Django and not Python, meaning that this command will actually only run once you have installed Django. And what this does is that it instantiates the prerequisite database and tables that are required by the base model created by Django. And to create a base model, you have to write Django-admin start project and the name of the project. Since I wrote my site, so my site was created for me. And then if you have to create an app, now apps are basically sub-modules inside your project which may be used to create different pages for your website. Now since I wrote the command python manage.py start app, name of the app, the name I have given is polls. So once you create a project, this my site directory would be present and inside just my site directory would be present with the settings files and WSGI file. Once you create an app, this polls app will be created with some migrations, admin file, app files, view files, these URLs and this video game model.picker is something that I have created. These were not in my base files or folders. Okay, so now you know how to set up the Django project that I created. Now understand this that you don't have to run these commands. This is only to make you a little bit more aware of how this project was created. Okay, you don't have to run in both of these commands. The last thing you have to do now, just to test this code out if it is running or not, is by typing in this command python manage.py run server. So once you run this, I would say once you type this out, it would, yeah, it's basically better to show you rather than just tell you what this does. So once I do this, so now it looks for the code and starts to run the code in a local environment on your PC or laptop or whatever. Okay, so now it's telling you that it's performing system checks, and once it's done that, it would give you an URL. Okay, once you click on the URL, now my laptop is pretty slow. It won't take so much time for you. So yeah, you can see a web page, basic web page having forms is loaded. Okay, so this is what run server does. Now coming back to the code, let's first understand that an app is a submodule that helps you building web pages for your website. Okay, and in your my site directory, inside my site directory, the settings files and URLs and WSGI file, ASGI files, these files are actually files that help controlling how the apps will work, how the Django base app will work, or I would say the Django project itself will work, what middlewares to be used, if there's a database, how will we are handling connecting to the database. All of that is present inside here, and changing these values will result in different kinds of responses from Django with other third-party softwares like database handling servers and etc. So if we go to the settings part, you can see a lot of things that you might not be able to understand. So these are our installed apps. Okay, since you can see that all of these apps were actually pre-built. Once you start in project, some pre-built apps, some pre-built middlewares, some pre-built stuff is already given to you. And on top of that, what you can do is create your own stuff or maybe modify the existing files. So this is me creating new stuff, that is new app, from which I'm creating a web page and running that web page and using forms to get the data and then use that data to predict, which you will see later on. So you can see a lot of middlewares are present. Now you don't have to, search for each and every middleware or which is to be used. It already gives you some of the common middlewares that helps in maintaining security, decreasing vulnerability of your site. Okay, then next is here. You can see that the database handling is done or connections for database is done. So Django provides you with SQLite 3 connections and I would say it's a package of database to be used by Django. You can change the values and set it up with Postgres or maybe MySQL or some other services for database. Okay, that is done through here. Then yeah, so here we are creating a static root. Basically this is a URL. I would say this is a part to a directory where all these static files would be saved when we are moving to production. Okay, you can see that static files are CSS, JavaScript and images. Finally, you can even go to the Django project or the Django docs to understand how to work through it. And the docs are very well prepared in the sense that they don't just give you or throw the theory out on you. They actually provide you with examples and a tutorial where you can build a basic project, build apps, connect apps, use databases and such. Now, even if you think that you're not able to understand much of whatever I've just said, you can just refer to the docs. Okay, since the main part of, I would say the main part to understand is not present in settings, but actually in views. Okay, so views is actually present in your apps, and one view is particular to one app. Okay, so this is the page, or I would say this is the Python file inside your app where rendering of new pages, handling of data from front end to back end, storing data, retrieving data, outputting the data from back end to front end, all of these functionalities are present here. Meaning, if you want to render a data, if you want to render a page, you create a function, okay, and use this. Oh my God, it's lagging. Yeah, use this render, as you can see here. Use this render function to render index.html page that I have made and even send context to that page. Okay, now again, for people who have no understanding or maybe haven't learned web applications and how to build web applications, it might be confusing to understand what is rendering, what is context. So context is basically information that you want to send from your backend to your front end so that you can display or use that data later on. Cool. So what we are actually doing is, let me show you the page. So this is the page that I have built. Okay, a basic HTML page having forms, taking in inputs that I have also showed you once I was using the run server command. So this is the forms, and once you click on the button submit, what happens is that all of the data that was input by you is now sent to the backend, whereas in views and stored in different variables that I've created. So this part is actually where we are storing the data, and now that data is sent to a data frame. That is, we are building a data frame and inserting all of the above data into that. And once I've done that, this is the insertion part. It looks pretty big and confusing. I will tell you what I've been doing here. So once data is being input or inserted, I'm loading the pickle file, that is my loaded model, and using the predict function from the loaded model to predict the value, that is the prediction for the value of other sales, and storing that in my results variable and sending that result variable as context. Now you might be thinking, what are these helper functions? So understand that in my final data set that I gave to the model, there were a lot of categorical data types, yeah, and we extracted them by creating new columns. So to fill in those columns, what we are doing is basically taking only one value. Let's say in this category, we took electronic arts as the value. So electronic arts would be sent into the backend. Yeah. So electronic arts would be sent into the backend, and what we are doing is using a helper function. Let's go for, yeah, in this pub function. Yeah, you can see if electronic arts was selected, then an array is returned with zeros and one values. Now, if you still haven't understood, this means that now all of those categories will be filled using this array here or list here. Okay. So since electronic arts was selected, then the second value will be 1, the rest will be 0. If activation was selected, then first value. If Konami was selected, then third value would be 1, the rest will be 0. So this is like similar for each of the functions or helper functions that I have created. Okay. Now the last thing I would like you to take notice of is that these functions, def func, console func, are different as compared to this index function. You can see that the parameter is request here, and the parameter for these function is just x that I defined. So what is the difference? If a function is taking request and maybe some more parameters, then that means that this function is specific and related to one page of a front end. That means this function is responsible for rendering that page. Okay, this is the difference between a simple helper function. Now this function, since it doesn't have any request parameter, it is not responsible for rendering any of the pages. Okay, now some people might be thinking, how is this function directly able to be mapped to this index.html and is able to render the page? This is with the help of URLs, where we build a path, meaning that at this path, this index function will work, and now once this index function is being called, it would then render the index.html page. Cool. So this is how we have been in getting the data, using that data for prediction, and then sending out the predicted output. So this was the second part, and now that we have finished the second part, we will move on to the third part, that is deploying on Heroku. And in that, I would also introduce you to some of the files that I have created beforehand. Those are procfile and runtime.txt, and why do we need. Hi. So this is the third part of the course where we are going to deploy this web application that is based or built on Django framework to Heroku. Now before we move forward, I was going to tell you about two files that were procfile and runtime.txt. Now runtime.txt is basically just telling Heroku which language or base is to be used by the server. Meaning If I just click here, see, it is telling Heroku that Python version 3.7 is to be used. In Procfile, the Procfile is the mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that I specified in the last part, like run server or migrate, these commands are actually executed in Heroku server using or with the help of Procfile only. So in Procfile, yeah, here you can see that gunicorn is actually taking help from my site .wsgi, basically the WSGI file, and handling the commands that are to be run by Heroku so that the code can be set up on the server also. Okay, so once you have cleared what runtime.txt and procfile are, another thing to notice is that here the secret key is directly kept, meaning anyone who can access the code can see what the secret key is. So security warning is also given that keep the secret key used in production as a secret, meaning that you can use environment variables or you can use different methods where you can save the secret key in some file and access that file and get the input here rather than directly storing the secret key. Another thing is about the debug is equal to false. Now when debug is set to be true, there Django will directly tell you about all the problems or errors that are coming in your code and even showcase those errors directly on the site also. So we don't want that because a subpart of the code will be shown, all the errors that are coming will be shown on the website, which we don't want, as the users will directly be able to see the code itself. So that is also to be set false, and then allowed host. This basically tells you that the host, which is the local server, can access this code and use this code to render the pages. And this, I will tell you where this actually came from. Okay. So once we have set all of that, what we have to do is now go on GitHub and upload the code there. So as you can see, I have uploaded the code here. So in my account, I have a directory, or I would say I have a repository, video games here, and there in the master branch, I have the code saved here. You can even see that there is an environment and that environment is active. What this tells you is that this is connected to some another software where an environment is set up for this code. So that software is actually Heroku. Jumping to Heroku, what you have to do now is basically go on new, create a new app, and once you click on that, yeah, once you click on that, it will ask you to set up an app name, and what you have to do then is just click on create app. Now since I've already created an app, I'm going to directly go there. So the app I created is video game sales. So once you create a new app, this dashboard kind of thing is what you're going to be seeing, and there if you click on open app, in open app you can see the link is provided. You just copy this URL, or that's what I did. I just copied the URL and then went in my site settings.py and saved it here. Okay, this is the, so this link actually, or this URL came from here. Now you have to set up the app also so that it is configured and can use the code you have saved in your repository in GitHub. So first go to settings. In settings, click on add build pack, select Python and click on save changes. Once you do that, something like this will be shown here that Heroku/Python is now selected. Okay, go back to your deploy. Now once in deploy, you will choose the GitHub Connect option. Okay, because this directly help. This is really basic and is easy for a beginner to deploy your code with much ease on Heroku. So once you click on GitHub Connect, it would ask you to sign in. So put in your credentials, and once you do that, here it would ask you to select one repository. Okay, so one repository you have to select, and that would be connected with one app from Heroku. So you can see that I've selected the video game sale. What will happen is that a search bar will be given where you can type in the name of your repository, and once you search, it would give you an option, and once you click on that repository name, then it would connect. So you can see that this video game sales repository that is inside my account SID278 is connected. Okay, and then a disconnect option is also shown. Then you skip the automatic deploys and go to the manual deploys, where you choose the branch. Since I have saved the updated code in master branch, I select the master branch and I click on deploy. Now this is going to take some time, because now here the Heroku server is actually being set up so that the code can be set there, and then the server is able to use that code. So here you can see that the build pack is Python. It has detected from runtime.txt which Python version is to be used, and now it is now setting up all the packages and dependencies from requirements.txt. So all the packages are being installed now. Once it has done that, it runs a collect static in no input command that is again specific to Django. And what this does is collects all the statics files all over the, I would say, project, and stores it into a static files directory that you can see here. Once it does that, it compresses all the files into a required format and then releases the Heroku app, meaning now you can, meaning that the app has able to deploy your code, and now you can directly access the code, I would say access the pages from this button, that is view. So once you click on it, so that page that I showed you in the previous video, where when we use the run server, that page is now loaded here. So once I just, let's say, year of release, I don't remember, I would say this, and yeah, 39, 21, 7, 78, 89. So just filling this up, and once you fill this up, okay, I'm just filling it randomly, please don't kill me. And once you click on this, you can scroll down and see that the value for other sales is 7.58 for the scaling equivalent of 0 to 40 that was defined by the dataset only. So see, this is working. Now we have completed the third part also, where we have deployed the code and we are able to use that also.